Hello friends, welcome to Smart Engineering Academy. This is an online video tutorial on Etabs software. So here we are going to see what are the steps which are followed for the analysis of structures using Etabs. Firstly, we will draw some drawing in the AutoCAD. Later, we will define the terms like geometry of the buildings. In the geometry of the buildings, we will see the how to draw the grid lines based on the AutoCAD drawing and the number of stories we require. Later in the Etabs, we will define the terms like the material properties. So in the material properties, we will define the what type of concrete it is and what type of steel we are going to use for the building. And next we will define the frame sections like the size of the beams and the columns. Later the slab sections, and next the load cases. So in the load cases, we will define the live load, dead load, and the earthquake load, the wind load, and the wall loads. Later the load combinations and the mass sources. So after defining the terms, we will assign the properties to the members. Like first I have told that we are defined the size of the columns, beams, or the slabs. Okay. Later at the bottom we will fix the base of the model. Later we are going to assign the loads which and all we have which we have already defined in the previous slides, like the live load. As I told, the live load, dead load, and the SDL. The SDL means the super dead load. Okay. Later we are going to check the model, and later we are going to analyze. Later we are going to design, and lastly the last step is we are going to find out the output results. So as I told that in the first step we are going to define the AutoCAD drawing. So here is the AutoCAD drawing which I have already drawn. So this is in this we are going to find out the X direction and Y direction. So in this AutoCAD drawing, we can see that there are 5 bays in the X direction. This is 1, 2, 3, 4, 5 bays, and also in the Y direction it is 1, 2, 3, 4, 5. Okay. So simultaneously we need to note down the number of lines in the X direction and as well as in the Y direction. So here we can see that there in X direction there are 6 lines. So 1, 2, 3, 4, 5, and 6. Similarly in Y direction also there are 6 lines. So this will be helpful in case of drawing in the Etabs software. So the distance between the two bays is 5.3 meter in X direction and as well as in the Y direction. So now let us open the Etabs software. So this is the window of the Etabs software. So first we are going to define the new model now. Okay, go to file, take the new model. So when you take the new model, you are going to use the built-in settings. So in the built-in settings, in India we are using the metric system. Okay, so since the steel sections are in the Indian size and the steel design code is IS 800 2007, and based on the concrete design we are going to use the IS 456 2000. After defining all these things, press OK. So this is the window after defining all the terms. This is the window which we are going to see. So here we are going to note down the number of stories, means how many number of stories we require for the model, and we are going to define the typical story height, means the floor to floor height we are going to define. And here we are going to define the bottom story height. Usually we are going to provide the bottom story height as 3.2 meter. Okay. So as I told that in the AutoCAD drawing, we have the number of grid lines in the X direction, Y direction, and the spacing of grids in X direction and as well as in the Y direction. So as I go to the AutoCAD drawing, the first step is the number of grid lines in the X direction. So as I see in the X direction, there are 1, 2, 3, 4, 5, and 6 grid lines. So here I am going to write it as 6 grid lines in the X direction. Similarly, if I go into the Y direction, it will be 6. Okay. So here also I'm going to write it as 6 directions. So spacing of grids in the x direction means, as I told, that the spacing is nothing but the number of bays. Okay, so there are 5 number of bays in the x direction and 5 number of bays in the y direction. So this is a type of a symmetrical type of a building. So number of grid lines in the x direction is 5, and number of grid lines in the y direction is also 5. Okay, so after that press OK. So later the window will appear like this. Okay, this is the window we can see after defining all the terms, that is the story height and the spacings and the number of grid lines. This is the 2D window frame, and this is the 3D window frame. Here we can see that already I had defined that there are 4 stories. So here is the 4-story building I had already got. So if I move down towards, here is the story 3, and this is the story 2, this is the story 1, and this is the base level. So as we all know that in the base the foundation will come, and in the story 1 there lies a plinth level. In the story 2 the normal building will start. Okay, so let us go to the story 1 now. As I told in my this thing, we have already carried out the AutoCAD drawing. Next step is we have already defined the geometry of the building, that is grid lines and the number of stories. The next step is what? We are going to define the terms, that is the material properties, frame sections, slab sections. Okay, so here is the icon here. We are going to define the terms now. As I told that so in the define there are number of options. So in the first we have the material properties. As I told that in the material properties we will define the what type of concrete or the what type of steel we are going to define. Okay, so click on the material properties. Later we are going to add the material properties here. So since our country is India, we are going to select the India. Material type is, we are going to select the material type, and standard is Indian. Later we are going to find out we are going to find out how much grade we are going to find out. Let us take the M25 grade of concrete. After refining all those things, press OK. So here it comes the properties of the M25 grade concrete. Then next we are going to define the rebar. Rebar is nothing but the reinforcement we are going to define. Okay, so here is the rebar term, and here it asks the grade of steel, HYSD 415, 500 or 550. So here I am going to take the HYSD grade of 415 steel. Okay, press OK. Later it gives all the properties of the HYSD 415 bar. After that OK. Then next press OK. So we have already defined the material properties. So next step is as I told that we are going to define the section properties. So in the section properties we will define the column size or the beam size. So column and beams both comes under the frame sections. So press the frame sections. So when I click the frame properties, this is the icon which comes on the frame properties. So these are the unwanted frame properties, so I am going to delete them now. So here is the option, delete multiple properties. Select this option, press Ctrl and select all those things and delete the selected frames. Similarly these two also I don't need. Then press OK and OK. So now I am going to add a new property, that is either I am going to define the beam or the column. So here is the term, add new property. So now when I press this add new property, I will get this kind of toolbar here. So I am going to define whether it is a rectangular beam or a circular beam or a circular column. So these are the different types of concrete structures, we are going to define them. Similarly, the type of steel or the type of the composite sections or some special type of characters. So now I am going to take the rectangular section now. So when I press the rectangular section, here it asks the property name. So here I am going to give it as a beam of size 300 into 300. Okay, so I am going to define the beam as the 300 into 300 section beam now. So the second step is the material it is asking. So in the material already we have defined it as a M25 grade of concrete, so you need to select the M25. So here it is asking the depth and the width of the beam. So since I have already defined the beam section as 300 into 300, the depth will be 300, and also the width will be 300. So as I change here the dimension, automatically the size of the beam goes on changing here. Okay, so the main difference between the beam and the column lies in this part of the section now. So here is the reinforcement. So press the modify show rebar. So now here it is giving either you are going to define the column or the beam. Since I am defining the beam section now, select the beam. Okay, so when I select the beam, it asks two things, that is rebar material. As we have defined the rebar material as the HYSD 415 in the define property, so when you define the material properties there, automatically here it will come. So select the HYSD 415, and then next it is asking the cover to the beam. So I am giving the cover as 30 mm for the top bars and also 30 mm for the bottom bars. So after pressing these things, press OK. Then later press OK. So after pressing all those things, you will already define the beam sections now. Okay, so already beam has been defined now. So the next step is we are going to define the column section. So similarly, as you have defined the beam section, again you need to go for the add new property here. Again we are going to select the rectangular section. So as we have already defined the beam section, now it's the time to define the column section now. So write here COL, that means column. So write down the dimension of the column. So here I am going to give the dimension of the column as, so I am defining the column section as 300 into 600. Similarly, as you all have defined in the beam sections, same type you are going to select the material properties as M25 grade of concrete, and the depth of the beam as the 600 mm, and the width of the column as 300 mm. So the as I told that the major difference lies in the reinforcement part here. So click on the modify show rebar. So this is the major thing. So now now as I am going to define the column section, click on the column section here. Similarly, the rebar material as we have already defined, that is HYSD 415, the confinement bar as the HYSD 415, and later in India we are going to use the 8 mm 5 stirrups. These are nothing, confinement bar are nothing but the stirrup sizes. Okay, later filling all those things, press OK, then next OK. So by pressing OK, here is the column dimension which is already defined. So only two things we are going to define in the frame properties, that is the beam and the column. Later press the OK. So the as I told in my this thing, that is material properties is over. The frame sections, that is beams and columns, we have already defined. Next step is we are going to define the slab sections. So again, if I want to define some material or something, again I need to go for the define toolbar. Later section properties. In the section properties, frame section is already defined now. The later we are going to define the slab sections. So press on the slab section. So here it is asking similarly as you all have defined in the beams and the columns, similarly here we are going to add new property. So here it is asking which type of slab you are going to build. So first I am going to define the one-way slab. So property name is one-way slab. The slab material which I am going to take, as usual, as you have defined in the beams and columns, material type you have taken it as M25. Similarly, the slab material also you are going to take it as M25 grade of concrete. So the modeling type is, I am going to take it as a membrane. The main intention of taking this membrane is it will transfer the loads which are coming on the slabs to the beams and to the columns and later to the foundation. The transfer of the load obviously takes place in case of any structure is from the loads will act on the slabs, and the slabs will transfer the loads to the beams, and from the beams the loads are transferred to the column, and from the column the loads are transferred to the foundation, and from the foundation finally the loads are transferred to the earth. Okay, so next, since we are using the one-way slab, this is the major difference between the one-way slab and the two-way slab. If I tick this button here, it will show the one-way slab. If I don't tick this button, it will show the two-way slab. Since I am using here one-way slab, I am going to tick it now. So the thickness of the one-way slab I am going to give it as 150 mm. So these are the things already I have defined. After defining all those things, press OK. So here is the one-way slab which I have already defined. Similarly like one-way slab, we are going to define the two-way slab now. So click the button on the add new property. This is change the property name as two-way slab. The material will be M25 grade of concrete. The modeling type, as I told that it is a membrane type. Now I'm not going to take this one-way slab button because I am using the two-way slab now. So the thickness also I am going for the two-way slab is 150 mm. So after defining the one-way slab and two-way slab, press OK. So till now we have defined the beams, columns and the slab sections. So in my presentation, the next term we are going to define is the load cases now. So similar type, go to define, later go find out the load cases. So now go to load patterns. So as you click on the load patterns, this is the icon you can see here. So it is so here is the which type of load you are going to use, the type of the load, self-weight multiplier, and these are the number of codes for the earthquake or the wind type of load. So since in the first step I am going to define like it's a gravity type of structure. So already the dead and live load is already defined. So now I am going to define the wall load. So the wall load will be also in the form of dead type only. So after defining the wall load, press the add new load. So when you press this add new load, the wall load will be already defined now. So as I told that the super dead load, so super dead load can be represented as SDL. So the meaning of the super dead load is, as we all know that in case of the RCC structure, we will multiply the 1.5 factor, that is the factor of safety. Similarly, the super dead load indicates that some extra amount of load we are going to apply on the structure now. So the SDL, so the load name will be of SDL, that is super dead load, and the type will be of super dead. After pressing the super dead type of the load, then next add new load. So these are the four major things which are required for the gravity type of model now. So since I'm concentrating only on the gravity type of model, I have defined the four types of loads. So after defining all these four types of loads, press OK. So now we have defined all the properties. So later, so after defining all the properties, now we are going to assign the properties or the draw the beams columns to the model now. So since I am not clearly visible the background, I am going to change the background color now. So go to options, press the graphics color. So in the graphics color, here is the one term called as the display. Press the display. So here it is asking the screen type. So since I have given the white background, it is showing me the white background. So the here are the four options. So I am selecting the black background now. So after selecting this black background, press OK. So now I can clearly visible the number of grid lines which I have already defined in the first step. Now go to draw. So first we will draw the columns. So go to draw, select the option as draw beam column or the brace objects. So when you select these objects, here it comes. So the third option will be of quick draw columns. Select this quick draw columns. So when I select this, here it comes the properties of the objects. So select the property now. So since you have defined the column section as 300 into 300, select this 300 into 300 type of the column now. So like this type of toolbar will come. So go on pressing on the grid lines. So similarly like this. So I can understand that here all these types are columns now. So as I go on pressing, here the 3D view will come. So I want the columns along from first floor, from the base of the foundation to the top of the floor. So here what I am seeing is that only up to the first floor the columns are placed now. So the main intention of this is change the, here is one icon here. Here it is showing one story. Since I have selected this as one story, only the one story has the columns has appeared. So here it comes the all, select the all stories. Okay, so here is the, so since I cannot I cannot overwrite on these columns, so I press escape and press escape. When I press the escape, these properties of the columns will disappear. Later drag on these columns so that the columns get selected. Press the delete option. Okay, since I have selected the all stories as my option, now again go to draw beam column brace objects, select the quick draw columns. So here is already, since I have selected the column the property as the column 300 into 600, automatically when I press here, my all the stories will get assigned by the columns now. Similarly, draw the columns along all the grids. Even I can change the angle of the column, that is the orientation of the column, that is by pressing it as 90 degrees I can orient the columns direction. See here, now the columns orientation of the column has changed now. Okay, so this is how the columns are drawn. So after drawing the columns, now the main intention is to draw the beams now. So again go to draw beams columns and select the first option, draw beam column brace Okay, so type of the line is frame. Property, as you all have defined the property as the beam of 300 into 300 size. Select this, go on joining the columns. So before that, see whether the uh, see whether the see whether it has selected the all stories or the one story. So go on drawing the beams now. So now I have drawn the beam sections now. So after drawing the beam sections, the main intention is to draw the slabs now. Similarly, go to draw. It will be in the form of floors. So draw floor, wall or the plan. So since I select the slab, so here it comes the property name. So whether I'm going to select it as one-way slab or the two-way slab. Since my dimension is of 5 into 5 meter, it will be obviously, so since the dimension is of 5 into 5 meter, this 5 into 5 meter, it will be obviously two-way slab. The difference between the one-way and the two-way slab is, if the length to depth ratio is greater than 2, then it is a one-way slab. If the ratio of L by D ratio, that is the length to depth ratio, is less than 2, then it will be a two-way slab. So in my case it is 5 into 5 cross section. So here I am going to use it as a two-way slab now. So while drawing the two-way slab, select the two-way slab. Here we need to take care that at each grid point we are going to click it. 1, 2, 3, 4, and one cyclic order we need to place the two-way slab now. Similarly, like the second one, so as the slabs are drawn, you can see it in the 3D type of the model. So you all see in the 3D type of the model now. So as I draw here, automatically all the slabs will be assigned to all the floors. So if I consider it as a one story, only the one story will be assigned with the slabs. So I want the slabs for all the stories, so I am taking it as the all the stories now. So if suppose the one way type of the slab if I am going to use, then I am going to select as the one way slab, and for the two base I am going to use it as a one way slab now. Either you can go it in the clockwise direction or the anti-clockwise direction. So the major difference between the one way and the two way slab is the direction. So if this direction comes, means it is the one way slab, and this is the two way slab. So this is the representation of the one-way slab. So this symbol indicates that the loads are going to distribute along these directions. In the same way, draw the slabs for the all the sections now. So as I know that since it is a 5 into 5 cross section, so since I have used the one for the representation of the one way slab, it comes under two way slab now. So select these two slabs and press the delete option, and again draw the one way slab now for this. So go for the draw floor or wall objects, draw floor, select this, and here I have to select the two-way slab. Similarly, draw for this two sections. So now we have already assigned the columns, beams and the slabs now. So we are, as we can see that we are in the story 1 now. So the main is go to base floor. So we can see that in the base floor there won't be any slab. The base floor is nothing but the foundation level. Okay, so the slab won't come in the foundation, so we need to delete the foundations here. We need to delete the slabs here. So here we need to take care that now we need to select the story 1 now. Since so the main intention is we are going to delete the slab at the foundation level. If I select the all stories means all the slabs will be deleted. So select the one story, select the select each bay. So after selecting all the bays, press the delete option. Okay, so after pressing the delete option, now as I told that at the foundation level we are going to restrain it. So restrain is nothing but the we are going to fix the foundation here. So for fixing the foundation, go to assign, joints and restraints. Okay, before before going to the restraints, you need to select all the columns here. So drag the button. So by dragging it, you can select the all the uh, all the columns. Then go to assign. We are going to assign. We are going to fix the joints now. Joint is nothing but the foundations. So joint. Then next restraints. So in the restraints part, you can see here fixed one. So the first one is the fixed type, the second one is the hinge, the third one is the roller support, and the next one is the pinned support. So as I told that the foundation will be of the fixed support, so select the fixed option. So when I select the fixed option, all the rotation and the translation will get ticked, and by selecting this foundation, later you apply them. Then press OK. So by pressing OK, the foundation will be fixed now. So as I go upwards, this is at the base, and this is the story 1. The story 1 is nothing but the plinth level. So so we can see that in the plinth level only the outer beams will come, the columns will come, and the slabs and the inner beams won't be there in under the plinth level. So I need to delete the slabs and as well as the inner beams. So as I told that, select the one story option, select all the slabs. So after selecting all the slabs, press the delete option, and similarly as I told that the inner beams won't be there, select the inner beams by dragging it from the right to left side, then press delete option. Similarly from bottom to upwards, press the delete option now. So here comes our plinth level. So from the next story our actual structure will start. So finally we have applied the material properties. We have defined the columns, beams, the slabs and all. So in the next concept involves the application of the load or the applying the loads. So it will be explained in the part 2 of our Civil Engineering Academy. Thank you.